Day 21 of Advent of Cyber. Let's dive into the storyline and see what's happening in the city of Wereville and where can we help the elves prepare for their Sockmas and prevent any chaos from King Malhare. Let's get into the storyline and see what's there. And in our kingdom of Wereville, just like any others, thousands of files of all kinds passes through the system every day. From docs, PDF, resumes received from our elves, to financial spreadsheets, CVS from accounting departments, and executable files launched by different applications. But have you ever wondered which of these might be malicious? Which one could actually belong to King Malhar? An interesting question, isn't it? Today's learning objectives is that in this task, the best festive company's SOC team will investigate one specific file type, HAT format, HTML application basically, format, a type often used for a legitimate purpose, yet just as frequently exploited by attackers. Your machine is to reverse engineer the hat and uncover how King Malhar tricked werewolves elves. To do this, you will have to look for application metadata, script functions, any network calls or encoded data, clues about exfiltration connecting to the machine. Before moving forward, review the questions in the connections. Okay. Anyway, we have gone through this. So we just have to click on the attack box. Click on the start attack box button at the top and open malware sample using plum root rooms. Okay. So let's copy that itself. Then paste it right there. I guess we'll have to open it using terminal. Oh, it opened my terminal. Let's open terminal here. First, let's make sure the window is sufficiently big. Yep. And here, let's paste the command. And that's opening this tool there. Okay, so we have some HTML code here. I guess there'll be some explanation about it. It's in the next section, but there's some important note here. The room uses hat malware file. It's safe, but do not run it locally. For safety and intended experience, you should use the attack box. The files is already provided there. If you download it manually, browser may block it. If it does download, open it only in a text editor and do not execute it. Yes, whenever you have a malware and doing some sampling, please do not open it on your local machine. Either have a isolated machine like a virtual machine or any sandbox environment that you prefer, and know that is safe and there will be no infection which is spreading outside that box. So in only such cases open it. If not, just ignore it. Don't run it on your host system. Anyway, let's get into the next section to understand about hat overview. Not long ago, in the summer 2025, researchers discovered that ransomware groups were using hat files distinguished as fake verification page to spread Espil Sun Red ransomware. During the campaign, many organizations were affected, and the security teams were reminded how important it is to understand what hat files are and why they appear so often in corporate environments. So, what exactly are hat files and why do they exist? In Weville's digital kingdom, not every strange looking file is a threat. Some were originally created to make the daily work of developers and administrators easier. One such helpful invention is the hat file, short for HTML application. And hat file is like a small desktop app built using familiar web technologies such as HTML, CSS, and JavaScript. Unlike the regular web pages that open inside the web browser, hat files run directly on Windows through a built in command called Microsoft HTML Application Host, or MSHTA in short. This allows them to look and behave like the lightweight program which their own interfaces and actions. In legitimate use cases, hat files serve several practical purposes in Werewolves and beyond. Automating administrative or setup tasks, providing quick interface for internal scripts, testing small prototypes without building full software, offering lightweight IT support utilizes for daily use. In short, hat files were designed as a convenient way to blend the simplicity of web with the power of desktop application, a tool that many the best festive companies, engineers, and elves still use to keep SOCMAS operating running smoothly. Hat file structure. Before the defenders of the best festive company can recognize suspicious hat files, it's important to understand how a normal hat file is built. Luckily, their structure is quite simple. In fact, it's very similar to regular HTML page. An hat file usually contains three main parts: the hat declaration, the defines the file as an HTML application and can include basic properties like the title, window size, and behavior. The interface, HTML and CSS. This section creates the layout and visual such as the buttons, forms, or text. The script, VB script or JavaScript. Here is where the logic lives. It defines what actions the hat will perform when opened or when a user interacts with it. Here's a simple example of the legitimate hat file might look like. Here we can see HTML declaration of the code that is written. The head says title, the best festive company utility tool. Then it is describing about the properties of how should it look and all those things. It says ID, application number, border, caption, show taskbar, and all those things. Then comes the body. It says welcome to the best festive company utility tool. Input type button, values say hello, click on message hello from Wevel. So there's an input box also there. Anyway, let's get into this section of the reading. It says this small example creates a simple desktop window with a button and shows a message when clicked. In real cases, hat scripts can be much longer and perform important tasks. It's easier to see why developers liked hat. You could build a quick, functional tool using nothing more than web code. However, as best festive companies, defenders will soon learn the same flexibility that makes hat convenient also makes it powerful enough to require careful attention. How King Malhare turns hat into weapons. Hat files are attractive because they combine familiar web markup with script execution on Windows. In the hands of a defender, they are handy automation tool. In the hands of some wanting to bypass control, they can be used as a delivery mechanism or launcher. Common purpose of malicious hat uses. Initial access or delivery. Hat files are often delivered by phishing, email attachments, fake web pages, or downloads, and run through mshta.exe. Downloaders or droppers and hat can execute a script that fetches additional binaries or scripts from the attacker's C2. Obfuscation or evasion. Hacks can hide intent by embedding encoded data base64 by using short VBS scripts or JavaScripts fragments or by launching processes within hidden windows. Living off the land. Hat commonly calls built-in Windows tools such as MHTA, PowerShell, VS Script, etc. to avoid adding new binaries to disk. Inside an hat, you will often find a small script that may be obfuscated or encoded. In practice, this tiny script usually does one of the two things: download and run second stage payload, or open a remote control channel to let something else talk back to the attacker's server. These lightweight scripts are the reason hats are effective launchers. A single small file can pull in the rest of the malware. Here's a sample that King Malhare might try to use. So they have given us example snippet of the hat file. It says HTML head title angry King Malhare, and this is nothing but the application's declaration. It says ID is Malhare, application name is B, border is none, show task no, all those things are there. Then the script says PowerShell, then no profile, execution policy, bypass command, which nothing but opens and minimizes PowerShell there. Then it is running all these code, and we can see a base64 string which is right here. Yep, that's a base64 string, and we can even see it from here. It's trying to decode it there. And is it opening the C drive, or I don't know what the C means, but invoke web request, which means it's trying to download something, and then it's probably, yeah, downloading some script or something like that, or even uploading something. As you can see, the hat is very different from the simple example that we provided earlier. It contains a number of obscure elements that deliver a closer look. Let's walk through it. When analyzing hats, the title and the HTA application tags often reveal how attackers distinguish malicious apps. They might use a convincing name like salary survey or internal tool to appear safe. Always check these first. Secondly, these VB scripts blockers marked by script language VB script. This is the active part of the file where the attacker often embeds encoded commands or call external resources. Inside this block, we find a PowerShell command. This a pattern commonly seen in malicious hats used for delivering or launching. The PowerShell invocation contains a base64 encoded blob from base64 string. This is likely a pointer to further instruction or a download payload. If you see an encoded string, assume it hides a URL. Decode it reveals the attacker's command and control, which is the C2 address or resource used in the attack. Always decode before assuming what it does. Malware authors often use multiple layers of encoding and encryption, such as base64 for obfuscation, as some form of encryption or cipher to conceal the true payload. When you decode the base64, check whether the output still looks like gibberish. If so, the second decryption step is needed. For example, we will extract the base64 code of this and inspect it with a tool like CyberChef to reveal what it hides. Let's open that URL there for CyberChef. Let's copy this entire base64 code and let's do it here. Let's paste in the base64 and search for from base 64. Drag it and drop it right here, and we can see the URL there. It says https raw.kingmalhare.com, then C2, basically command and control server. It says silver ref heads main redact.txt. So it's trying to download some txt file from the C2 server. Heading back to the note here, in the example, we have redacted the remote resource and replaced the real link with the redacted txt file for safety. In a real incident, the string would usually point directly to the file hosted on the attacker's C2 domain. For example, a URL under kingmalhare.com in our SOCMA story. After the encoded PowerShell command, we can see the three keywords U, C, and B. Let's quickly break them down, what each of them do. U holds the URL decoded and the location from which the next script or the payload will be fetched. C stores the content downloaded from the URL, usually a PowerShell script or the text instruction. B converts that content into an executable script block and runs it directly in memory. Whenever you see a chain of variables like this, try to trace where each one is created, used, and passed. If a variable ends up inside a function like run, execute, or eval, that's a sign that downloaded the data and is being executed, a key indicator of malicious activity. As a summary, the process of reviewing a suspicious hat can be broken down to three main steps. Identify the script section, which is the VBS. Look for the encoded data or the external connection, such as base64 HTTP request. Follow the logic to see what executes or is being sent out. We reviewed how attackers might use an hat file for malicious purpose. Now that you have seen how hat can combine HTML, VBS script, and PowerShell, you will apply the same process to analyze the suspicious one. Start by locating the script section, script language VBS, then identify the function, encoded string, and reference to URLs or system calls. Decode anything that looks like it is hiding information. Then trace how the script uses the result. Now it's your turn to work out what the evil king's minions did. From surveys to security failings, our team figured out that some of the elves' laptops were compromised. Working through the incident, it seems that the one common denominator between all is a survey they completed regarding their salaries. The investigation found that an email was sent to these elves with a hat attachment. The team is asking you to review the hat file and provide feedback on what is actually doing. You can choose either the attack box and find it here. So I guess we have opened the survey.hat itself, or download the attached task file and perform your analysis. Use a text editor to view the hat to ensure that it doesn't execute. You can use plum on the attack box by running the following command. So we have already done that there. In the best case, let's also download the file. I guess it's here. Let's download the task file and just keep it in the background. Okay, let's go down here and yep, we were here. You will see the hat as follows. We get the same window there. We will start our analysis by searching for the metadata of the hat, which will tell us what purpose it is telling users it has. This section is denoted by the head as shown below. So we have the document type HTML, that is nothing but declaring about the HTML, and this is the tag which starts saying that it's HTML. The head says title Best Festive Company Developers Survey, which means it's telling the elves that the page is talking about a developers survey. Okay, so we get that idea from the head there. Also, it says some ID is given, application ID. Application name is Festival Elf Survey. Icon logo is set in, borders, and all these information is just passed in there. So yeah, I guess we can. Oh, there are also some scripts related to it. Which Where does the head end here? I don't know where the head ends, but somewhere it should. I did not see it in the top. I guess I saw it here. So head ends here. These are all part of the head. So this is going to just load up when the application loads up. Nice. It's interesting. Next, we want to understand what hat actually does. This means we need to search the VB script section. So script type text VB script. So this is the script which is used for JavaScript. So we can probably ignore in this case. And here we get the VB script right there. And this is using sub window on load call get questions. So it's calling some function called as questions. It's getting to get questions from somewhere. Oh no, it's getting from online source. So it's calling this function itself there. Fine, that's good. Looks something. I guess this is where all the malicious thing might be stored. Anyway, let's get into reading here. Window on load. This function will automatically execute when the hat loads and executes the get questions function. Get questions, the function makes some external request and then ultimately runs the decode base64 function and calls the provided feedback function with the data. See that here it's saying it's going to decode, but I guess this is the URL which it is requesting the data from, and then it's saying decode. It's taking the result in and then decoding it from base64 and storing it in the variable called as decode. Then the decode string is here, which is rs binary to string decode. Basically, it's converting string to binary there. Provide feedback string. The function gathers some data about the computer, makes some external request, and then ultimately executes something we still need to analyze. Decode base64. This function takes in a base64 strings and converts it into a binary. Then rs binary to string. This function takes the binary input and converts it back to the string. Okay, so this is doing the opposite. It's converting the binary data to the string data. Okay. Within these functions, we want to understand any real actions being performed. These are usually denoted by the create object. So do we see a create object here? We see this function create object. It says Internet Explorer.application. Okay. It says Internet Explorer.application allows the application to make an external connection. Then WScript.network connects the computer's WScript networking element to uncover information. Okay, so fine. So it's sending out information about the computer. Then WScript.shell creates a W script that can be used to execute commands on the computer. Fine, that's good. Lastly, we want to understand what the hat actually looks like to the user. Here is a very similar HTML file. To do this, we need to take a look at the body part of the hat, starting at the line 169. This part that will actually be shown to the users. So scrolling down, we can see it right somewhere here. After the head is over, yeah, it's the body here. So it's going to show the logos there. It's going to show the heading there as insert survey heading, then anonymous salary feedback, and it's giving all those things. So this is what is going to be shown to the users usually. How long have you been employed at the best festival company? So it's asking for some inputs there, and I guess yeah, it's basically asking for those inputs there. Okay, now using the information and steps given above, it is time to perform an analysis on the hat and figure out what the King Malhare is up to. Okay, let's get into the answering this question here. And these questions are mostly going to be based upon what is right there. So let's get into the questions now. First question is, what is the title of the hat application? So we can go up here and it's revealed here, Best Festival Company Developers Survey. Let's copy that from the clipboard here and paste it in here. Click on check. Next, what VB script function is acting as if it is downloading the survey questions? That is the get questions. So we can answer that directly here by typing it, get questions. What URL domain, including the subdomain, is the questions being downloaded from? Let's copy this, or it doesn't say HTTP, so let's copy this, survey.bestfestivalcompany.com, only till here, no need of that part. So let's take this from the clipboard, paste it in here. Malhaz seems to be using typo squatting domains that look same as the real one in an attempt to hide the fact that the domain is not the intended one. What character in the domain gives this away? So typo squatting is nothing but let's say if you have google.com as the domain, instead of GOOGL, it's going to have GOOGL. So it's making a small typo in the URL field such that the web page that is going to be commonly misspelled or commonly typed in a wrong form is going to result the user into going to a wrong site instead of the legitimate site. So something like that is also being done here. So we need to find that here. So survey dot best festival company.com. Even if there's a spelling error, I'm bad at spelling, so I would not get to know. Let's copy that. Let's copy this and let's separate these words there. Somewhere a typing error. No. Oh, festival. What is it? FESTI. Oh, it's double I here. Okay. So it is the letter I which is being it's the one which gives away that yeah, that is the wrong thing. So malicious hat often include real looking data like survey questions to make the file seem authentic. How many questions does the survey have? It's down in the bottom here. It is 1, 2, 3, 4. So there are 4 questions which is being asked. We can answer that as 4. That's done. Notice how even in the code social engineering persists. Fake incentives like contents or tips hide in plain sight to build trust. The survey and entities participation by promising a chance to win a trip to where. Oh, that's a common thing. When you want to build some trust, you give them something where they are desperate about something and they buy you into that story. So let's say trust and win you over that, saying that yes, this is a legitimate thing. So we're promising you this. It's kind of a typical social engineering thing. Okay, so how long have you been employed at the best festival company? Do you feel valued at work? Do you feel content with your current salary? How much would you believe your salary should increase? Okay, all participants will be entered into a prize draw for the chance to win a trip to South Pole. Okay, so that's where they're planning to go, to South Pole. Okay, the hat is enumerating information from the local host executing the application. What two piece of information about the computer is running on are being exfiltrated. You should provide the two object names separated by comma. Okay, let's get to the script part for getting this answer. So the question that it says, it's trying to enumerate information which is from the local host executing the application. So what gives away that? So here it's downloading all these information and it's decoding it here. That's what is happening there. Then coming here, it says provide feedback. And here it's connecting to the network, computer network, and username. So it's giving out the computer name and the username there. So computer name, comma, and the username of the user that has logged in. Let's click on check. Then what endpoint is the enumeration data being exfiltrated to? So where is it being sent to? It is being sent to details. So let's say slash details, then click on check. What HTTP method is being used to exfiltrate the data? Is it get? I'm guessing it is get. I'm not sure. Okay. And it's usually get because you use the parameter of the user name, and here basically you can see it here, right? So it's nothing but sending that data, and in the request log which has come in the servers, and you can see what data it has come. For example, I can show that case right here. Let's start up simple Python server uh, at port 80 itself. Okay, now if I go to local host on port 80, now I search for hi, I can see that information coming out here saying hi. So in that case, if I had something like hey, hey, you are there, so we would get something like hey, you are there. So you basically can get it from the get request also. That's the reason I just made a wild guess, and that seemed to be right. Okay, now next question. After reviewing the function intended to get the survey question, it seems that the data from the downloader of the question is actually being executed. What is the line of the code that executes the content of the download? Okay, so we see here that the question is being downloaded and it's being just converted to a string format there. And it says call provide feedback decode string. So it's passing that there. And this is where it is taking it in there. So it's taking in the username and the password from the computer's name and the username, and then passing it to the place there, or the attacker's place. Then we see this one. So it says run object PowerShell pop hidden feedback string set to 0 false. I'm guessing it's this uh, because this is opening the PowerShell script, and it's also maybe what, I'm not sure. I just want to give it a try, but there could be other functions also down here which is exactly running the questions which is downloaded. But anyway, I feel because it's opening a PowerShell script, this could be it. So let's copy this and paste it in there and check. Oh, that's right. So yeah. Now it seems that as if the malware site has been taken down. So we cannot download the content that the malware was executing. Fortunately, one of the elves created a copy when the site was still active. Download the content from here. What popular encoding scheme was used uh, in an attempt to obfuscate the download? So let's, I guess this is base 64. This is a classic base 64. Uh, base 64. Yeah, I mean, the reason why I can tell this is from a little bit of experience looking at it. And yeah, again, it proves it that it's base 64. Okay, decode the payload. It seems as if the additional steps were taken to hide the malware. What common encryption scheme was used in the script? So in this script here, we can see what additional parameters were being used. So let's make the window a little big. The function AABB, then it's opening all these things. Fine, but I can even see the flag here. I guess that's the flag which we need to submit. And if this is 65 and C length is 90, Uh, 65 plus 13 divided by 26 plus 65. And oh, I mean, yeah, 13 is there. I guess raw 13. I just want to try. Raw 13. Oh, yep. Yes, raw 13. Now, what is raw 13? I'll link the video in somewhere here, right or left. I have explained in detail about what raw 13 basically does. It's nothing but it rotates each characters for 13 bits from them. That's what this is doing. That's why it's taking the content and then adding up 13. For example, let's go through CyberChef itself, cyberchef.org, and I can show a demonstration of that here. So let's say I want to type in ABCD in the input box. EFGHIJKLMN. So this is my letters that I have of the alphabets. So when I use this ROT 13 operator here, it is going to convert each character plus to the 13th position of it. What is that going to be? It's going to print that as an example. For example, if you see here, A is there. A plus 13th character from A is going to be N. So that's the reason we get this to be N. In case of B, it's going to be B plus 13th character, which is the 0. That is how it's going to loop around. So from N, if I start to type O, P, Q, R, S, T, U, V, W, X, Y, Z, we can see that the same numbers plus 13th characters from them are being shown there. So that's the reason it just intuitively got to me that it's ROT 13. Anyway, let's continue reading here. Either run the script or decrypt the flag value using online tools such as CyberChef. What is the flag value? So we get the flag value, which is right there. And it's anyway ROT 13. So I will replace it here and we get the flag there. Let's paste that in and click on check. That's done. Now, for those who want another challenge, download the hat file from here to get the key for the side quest for accessing through the side quest hub. The password for the file is can you rem. So let's click on check and click on check. With that, we have finished the day 21 of Advent of Cyber. Meet you all in the day 22 of Advent of Cyber. Till then, stay happy, stay smiling. Thank you for watching. Bye bye.